So in this video, we're going to be looking at energy, and in particular, energy stores and power. A very, very important law called the conservation of energy is that energy cannot be created or destroyed. It can only be transferred from one state to another. So you cannot create energy out of nowhere, and you can't just destroy it and send it to nowhere. You can only change it from one form into another form. And this here means that in a closed system, the energy is constant. Energy is the ability of an object to do work. If you do work on an object, you are transferring energy to that object. If work is done by an object, you are transferring energy from that object. In other words, the work done is equal to the energy transferred. And these two can be used interchangeably. Now, the unit for energy or work is the unit of joules, given by this capital J. So 1 kilojoule is equal to 1,000 joules, and 1 megajoule is equal to 1 million, or 1 times 10 to the power of 6 joules. So let's look at the different kinds of energy stores and what these energy stores mean. So we have something called kinetic energy, and this is the energy possessed by a moving object. So any object that is moving will have some form of kinetic energy. There is something called chemical energy, which is the energy stored within the forces between molecules. And you find this in food and, let's say, batteries, etc. There's something called gravitational potential energy. This is the energy stored between the gravitational field of two masses. And in most situations, you're going to be looking at the gravitational field stored between a mass and the Earth. There's something called electrostatic energy, which is the energy stored between charged particles. There's also something called magnetic energy, which is the energy stored in a magnetic field. And finally, there is something called the elastic potential energy, which is energy stored in an object that has been deformed. So let's look at some equations. Let's start off with kinetic energy. Well, the kinetic energy stored by a particle is equal to half times mv squared, where here m is your mass of the object in kilograms, v is the speed of the object in meters per second. Now your gravitational potential energy equation is equal to mgh, where m is the mass of your object in kilograms, g is the gravitational field strength, and this either has units of newtons per kilogram or meters per second squared. Both of these are the exact same. So if you have 1 Newton per kilogram, you have 1 meter per second squared. And the value of G on Earth, which is going to be the situation for most examples that you encounter, is 9.81 newtons per kilogram, or 9.81 meters per second squared. And here h stands for the height above, usually the Earth's surface, and this is given in meters. Now this height here is your perpendicular height. So let's say I had the surface here and a slope, and I had a mass on top of this slope. If this length here was 10 meters, but this length here was 5 meters, the value for my height when I'm using the gravitational potential energy equation is equal to 5 meters. Now that is a common mistake that a lot of people will get wrong. Now my elastic potential energy equation is given by a half kx squared, where k is my spring constant, or it can also be called stiffness. And this is given in newtons per meter. And your x stands for the extension of your spring in meters. If your string or your spring has original length of 20 meters and you stretch it to 25 meters, the value for your extension here is 5 meters. It's the difference between final length and the original length. There is one more equation referring to the heat energy stored by an object, and that is Q is equal to mc delta T, where Q here is just your energy stored, M is the mass in kilograms, remembering that energy is in joules, C is something called your specific heat capacity, and the unit for this is joules per kilogram per degrees Celsius, and delta T stands for your change in temperature, and this is given in degrees Celsius. Now this equation here is something that we will look at in more detail in a later topic. Now the final thing I want to go through is something called power, and power is the rate at which work is done, or the rate at which energy is transferred. Power is equal to the energy transferred or the work done per unit time, where here E is your energy, P is your power, and T is the time taken. Your unit for energy is joules, your unit for time is seconds, so your unit for power is then joules per second, or it's given by this capital W, which stands for watts. And here 1 watt of energy is equal to 1 joule per second.
Now the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.